a long time ago, which is about a year and a half ago, really, when I joined Box, we were trying to translate our developer documentation. We had a website, developer.box.com, but we had a very large Japanese market. If your company works in Japan with Japanese customers, the way they operate there is very differently. A lot of reselling is done through partners, in our case, and those partners basically do the integration on Box's behalf. And these partners really need to work with our documentation, our developer documentation, quite intensively. And Japanese, spoken Japanese is just not that common in Japan. It's really low on kind of on the index of countries that kind of speak English fluently. So we did eventually get there, but it was a lot of work. So at that time, we were hosted on README. README basically allows you to make a backup. You export it, and then we thought, like, cool, we translate it, and then we'll just upload it again. Right? Seems pretty straightforward, pretty easy. Except, not that easy. Turns out, like, when you do import, and then kind of export and import kind of thing, you'd expect it to be symmetrical, right? If I create an export and I just import it over here again, I should be getting the same system at the end. Not how it worked at README. At README, we would get a lot of problems with like things just being out of order, certain tags that were exported just not being imported again. So what we thought was going to be a pretty straightforward process turned out to be a lot of work. Like, it took us like 10 seconds to create a backup, then it took us like 3 months to do that initial translation. But we thought, like, cool, then we can kind of start doing translations over and over again, and it should be pretty quick. But every import basically took us a month of painstakingly like ordering everything back into the order that we wanted it. And that wasn't everything, right? That was just the tip of the iceberg. There were many problems. Hard to translate. We had no audit trail. Like, we couldn't tell like who was writing what at which time. There was no review process because you can't kind of write a draft in README. There was no modularity. It was hard to refactor. And it was really hard just in general to just ensure that the documentation was in a good quality. So if you read that list, you're probably going, docs as code, that's the way to solve this, right? It's if you're not familiar with this, docs as code is a principle that's been around for quite a few years now, and it's I'll dig to it in a moment again, but you can read more about it on writethedocs.org. And basically, it says a couple of different things, right? It says, like, look, very simple, store your documentation in GitHub or SVN or whatever you want to use, but these days, a lot of it is in Git. Then build the documentation automatically, review the documentation as you write it, and like publish the documentation without much user intervention. So I was interested in that because I'd never kind of fully gone through that with any customers. And I was very interested in kind of like learning more about that, but I felt like there must be more to this. I think this is a pretty simplified model, right? So before I go into kind of the learnings that we got from this is, who am I? I'm Cristiano. I'm a senior developer advocate at Box, and I am also our developer documentation lead. Why am I our developer documentation lead? Is because I said we should fix this, and they were like, cool, you do it. Small companies. I used to work with Hoopy. I used to be developer advocate at PayPal. I used to scare the crap out of people here on stage by trying to onboard onto their products in 25 minutes. Not doing that this year, doing a serious talk. I also write at my own website, although I haven't done that in a while, but I do these kind of like breakdowns of like developer experiences there as well. I should be getting back to that, but just time. So Docs is engineering, right? That's the title of my slide, the title of my talk. What I mean with that is, when I'm talking about engineering, I'm not necessarily talking about architecture, right? I'm talking about software engineering, the thing that we're also very much familiar with. And within software engineering, we've got a lot of principles that we're all familiar with. We've got a lot of principles that we try to hold ourselves to, right? We have the idea that we should be writing modular code and that we should keep things simple and that we shouldn't repeat ourselves. And that we should anticipate change and do one thing well. You know, the Unix principle of doing things well. to test early, and lots of other kind of principles that are out there. What I'm trying to see is how we can take these kind of things and kind of apply them to like the docs as code principle, and kind of take the docs as code principle maybe like its logical kind of like next steps. And actually, if you read the docs as code book, and if you read kind of the website and all the conferences that go on about documentation anyway, there's a couple of things that are already really being talked about. And one of that is just the idea of testing and linting, right? So testing and linting, within software engineering, we have a lot of principles around testing and linting. It's the idea of like testing early, testing often, testing the parts, but also kind of testing the whole, right? Testing unit tests, but also kind of like doing full integration tests. So what does that mean for documentation? For documentation, it means that if you test early, you want to test at the source, right? There's a couple of things you can do there. One of the things we use for our documentation is part of our documentation is now built off of our API spec. Now, Spectral is an open source tool built by Stoplight that allows you to basically just validate your open API spec to make sure that it's actually correct specification. Because at the end of the day, an open API spec is just a JSON file, but not every JSON file is an open API specification. So you run that and it will tell you like all the problems that you have in your API specification. And we've actually extended this to make our definition of API specification even stricter. Like we wanted to make sure that every variable has an example, because otherwise we can't show examples in our reference documentation. So you can add your own rules. And you want to test the unit, right? So one of the other things that we really wanted to test was just spell checking. So of course, both for our API specification as our Markdown, we pulled out some open source kind of spell checking libraries, pulled those in, and we're doing automatic checking to make sure that we're not like trying to be extra cool and spelling fields with a Z. That's already caught like just by importing the old documentation and running that through this, it's kind of like caught so many weird spelling mistakes, inconsistencies. We have teams in the US, we have teams in Europe, there's all like different spellings in British English, American English. We're now actually kind of trying to stick to kind of like one actual language. And then of course test the whole, right? One of the things that we noticed is that we had a lot of internal links that were pointing to pages that just weren't there anymore. And the old system wasn't warning us about this, so we kind of started to create our own solution to it. Now, we moved a lot to like writing in Markdown, and one of the problems in Markdown is if you want to do a path, right, you often kind of have to go like, oh, well, this link is like a couple of pages up, and then kind of like relative to that. And the reason why we have to do that is because we can't use absolute paths because we're translating everything into Japanese and into English. So the root path kind of isn't necessarily the path that it's pointing to. So we did a couple of things. First of all, we made it just easier to just add our own kind of schema and say, hey, I just want to point at a guide. I mean this guide. And we did then the same thing for our API specification where we can say, oh, I'm specifically trying to point at this file. I'm trying to point at this API endpoint. But of course, we then also like added our own checks to make sure that all of these pages actually existed. Do all of these links actually exist all over the documentation? Do those pages exist in the API specification or not? So by standardizing the way we kind of structure our links, we suddenly have made it a lot easier for us to then kind of go and find out whether or not those links actually exist across all of our documentation. I think first time I ran it, I found like 120 broken links just by running it once. Now the nice thing is this runs every time we run our build process, right? So this is never going to happen again. We're never going to get to a point where we have 120 broken links again.
Famous last words.
Famous last words. Yeah, until our test break, obviously. But at least it's going to give us a warning, hopefully. So modularizing is another kind of principle that is very popular in software. It's the idea that you should kind of break things into its components to make sure that they do one thing well, that they allow for easy inclusion, and that you can kind of allow composition over configuration, right? So rather than kind of configuring things, you can kind of take multiple components that you've written, combine them together into some nice new kind of bits of content. Software, sorry. But we wanted to apply that same thing to our documentation. So one of the things that we ran into is, especially with our Open API specification, is this is our Open API specification once it's compiled. That is 20,000 lines. The reason for that is we have 176 API endpoints. We have about 80 response and request objects, so altogether it kind of compiles to like 20,000 lines of JSON. Well, if you try to load that in GitHub to edit, you can sit there for like 15 seconds for GitHub to like finally get around to like loading it, and then you start scrolling and it goes like, oh, wait, didn't load that yet. So like that didn't really quite work. So what we did instead is like we split our API specification into separate files. And each one of these is a YAML file. And we kind of came up with a very simple way to kind of like map a verb and a path to a file location. And we added kind of like, we grouped them together by kind of like grouping them in kind of logically grouped endpoints. And then within each file, we just had maybe like 50 to 100 lines with some nice kind of multi-line text that people could just step into and edit. And suddenly it became way easier for people to start contributing to our open API specification. Our engineers can just go in there, find that one file, go in, oh yeah, we're missing this field, let's add that in, edit, make a PR, submit, and it just gets shipped into the API specification. So one file per API file endpoint, one file per response object, and then we use another stoplight product called JSON, I think it's called the JSON Resolver, to basically like create these references that we can basically like load it all in, and it just resolves it back into one file that we build out and ship to an English branch. And that's like that 20,000 lines kind of file that we can then use to kind of like import into other places. Now another idea of like using composition is kind of to allow easy inclusion, right? So again, this is the same file. One of the things that we ran into is, for example, the idea that that file ID we had in a lot of different places, and we had a lot of the same text in lots of different places that we kept running into. So we kind of just extracted it, created a reference to it, and then we just put it in a file, and we said, hey, file ID, this is how we describe a file ID. And then everywhere that we needed it, we could just go, oh, just load that entry in there. And suddenly it became a lot easier for us to not have to constantly be aware of, well, if you change the text over here, you have to go and change it everywhere that we describe a file ID. And of course, we took this beyond the documentation as well, right? We created Modular UI. Our front end is like full-on React. So we were actually able to kind of use kind of like what looks like an HTML component in our Markdown, but actually like it resolves to a React component. So we were able to do quite interesting things. Some of it was very simple, like in this case it just creates a message that has a nice styling around it. We all have these in our documentation, right? They're either blue, orange, or red, right? Those are the three preferred colors for that. But we also have some kind of more interactive components. So for example, one of the things we ran into is like, every time our SDK team made changes to the SDK, they had to change the documentation that they had on GitHub for all the samples for how to use each method, as well as going into our documentation, our developer documentation, and updating it there as well. And they never did that. So what we ended up with is like, instead we just went into, so this is our Windows SDK, .NET SDK, and we just went ahead and we added these little tags, these little hidden HTML tags in all of our Markdown files right before the code block that described exactly that endpoint. And then we just scraped all the Markdown on every build. We just pull it down, scrape all the Markdown files, extract all the samples. And then what you can now do is like you can basically say in any Markdown file, you can say, oh, I just want the samples for that endpoint. And it will render every possible language that we find. So suddenly, like any language that we support for that endpoint, boop, it will just render it. If we don't have a Java one, that tab will just disappear. It's also allowed us to basically, through that, create overviews where we can now look at it and go, hey, which samples are we missing? Which ones are we actually lacking? Which ones are we using, but we don't actually have them in every language? But what is interesting, I think, is like we took that even a step further. So our Open API specification, it's Open API 3.0 that we use. There's a lot of tools out there that still use kind of the old spec, Swagger 2. Cool, we just have our CI backported, so we also have a Swagger 2 spec that is just the same file, but just as our Open API spec, but backported. But then we also were like, cool, let's auto-generate our Postman collection. So we have a Postman collection that's just auto-generated based off of our API specs. So every time we update our API specification, it updates our documentation. It pulls in all the new samples. It pushes it out to Postman. It builds out a Swagger 2 file. All of it kind of happens all at the same time. Which brings me kind of to the idea of like a pipeline, right? I think we develop software these days very much within the concept of pipelines, right? Things go through staging environments. Things go through, developers ship code. Things end up in a staging environment. It ships out. It gets approved. It gets reviewed, QA. You might do some A/B testing, and then eventually it kind of rolls out to the right environment, to the master environment, etc. The same things can be applied to documentation to some extent. So what is a pipeline, right? Pipelines do a couple of things. First of all, they ensure quality. So within the pipeline, we do our testing, we do our kind of like validation that our code still does what it's supposed to do. It maximizes our value because it allows us to kind of like ship to multiple locations quickly, faster, kind of like in parallel. And it speeds up delivery. But what I think is interesting, it also encourages responsibility because it basically says, hey, anybody who writes software, if you manage to merge this into master, it will ship, it will go live, it will be part of the product, it will go out there almost instantly. So for documentation, what does that look like for us right now? This is the key slide everybody wants to take a photo of. I'll run through for a moment what it does. So it kind of starts over here. So we have our microcopy, our guides and stuff. It's mostly marked down in a couple of YAML files, as well as our open API specification, which is mostly YAML. And then we just have Travis pick it up, do the spell checks, do all the validation, etc. And then it writes it back to an EN branch, which is our English version. Mostly as like, again, as markdown as JSON, as kind of compiled and sanitized sources. And then every time the EN branches get updated, or any time our SDKs change, or any time our Gatsby kind of source, which is our static site generator that we use, it kind of calls a netlify function, which is kind of a serverless function, which basically then kind of determines which of our stages to trigger, because we have a staging environment, we have a master environment, we have a translation environment for our upcoming Japanese full translation. And then Netlify will pull all those sources in, build the site, and then ship it out to Netlify, which we're using as our hosting provider. But of course, we took that even a step further, right? Like I said, we're not just building documentation at this point. Because we have great source materials now that we are validating and we're sanitizing, we're taking that a step further. So to start off at the bottom, we have a couple of different build servers actually. So at the bottom, we have our in-house build server. So every time our English sources kind of change, it creates a snapshot, translates it in-house, sends it off to our translation teams, and then writes back the Japanese file to a Japanese branch. And then every time that happens, Netlify will pick up any of these sources and build them out as documentation. But every time these sources change, Travis will also put it up, and currently, like, it's pushing out a Postman collection. And it's not just pushing it out in English, it's also pushing it out in Japanese, because we already have our specification translated. And what we're looking at in the future is also for it to like start influencing our SDKs. Currently, our SDKs are handwritten, but we're already kind of putting tools in place where we can start kind of putting, at least notifying us when our SDKs are lacking samples, lacking functionality, opening maybe a ticket, an issue, etc. And then, we're getting to the point where we can now like detect changes in any of the pages, any of our SDKs, and start maybe like auto-generating our change log, just creating that off of the source material rather than handwriting it every time we have a new release. So where are we now? This is a site, doesn't look very good because I haven't really involved the design team at all yet. That's kind of like next few quarters. We have about 250 guides or something by now. We managed to actually grow our guides by like 150% or something while we were doing this. Every page has this nice little like edit this page link at the top right. You can click on that, it'll take you straight to the source. Somebody can just quickly edit it, change it, and if they get approved and it get merged in, then it automatically gets shipped out, kind of allowing that that cycle of responsibility to kind of move forward. We have a API reference page, which basically has all our 176 API endpoints, as well as like exactly what parameters it takes. All of these samples on the right, they're all kind of straight being pulled from our SDKs and kind of integrated. And one of the nice things is like we also managed to kind of like allow people to play around with our API straight in the documentation, because it's not just a static site generator, it is actually just a React app to some degree. We're suddenly able to add these kind of bits of interactivity in it so people can just play around, get the items in a root folder and kind of see the responses on the right-hand side. Build in our own search, of course, and of course we've also started to doing our translation to Japanese, which was the whole reason why we pretty much started this off in the first place. So currently, like we have just the API reference available in Japanese, which is already proving like ridiculously useful to our Japanese teams. But we're planning to ship the full site completely fully translated by like the first or second week of kind of February. That's what we're aiming at right now. It's a large kind of translation initially, but once we're there, every 2 weeks, snapshot translation, and it's fully automated. I don't even have to get involved in it, which makes me very happy. And of course, it's like fully mobile. It's a PWA. It works offline, all those kind of things, because modern web technology is cool. So to recap, I think Docs as Code is an awesome principle. Like there's an awesome amount of content written on that. But I feel like personally, there's so much value we can get if we don't just treat our documentation as code, but we treat it as a proper engineering project. So beside these kind of points of like storing docs in version control and building documentation automatically, reviewing and publishing without user intervention, I feel like we can also get to the point where we can say, look, let's add to that a little bit and say, test anything that can be tested, right? Let's make sure that your documentation quality is going to remain good. It's going to remain good going forward. There's no regressions, and every time you run into an issue, just like with software, cool, let's make the build fail first and then fix it, right? Those kind of things. And then modularize to prevent duplication so that we can reuse our documentation, not just within the documentation, but also reuse our source material to maybe create other content that we weren't creating before. All of that will allow us to reuse to maximize value, and I think using a pipeline is the only way to kind of tie all of that together to make that kind of scale to some degree. So that to me is like, I think really like the value of Docs as Code if we kind of like take it a little bit further, a little bit broader. So that's it. Thank you very much.